All right, so let's start with a quick review. See if you still can retain what happened last week. Now, again, it's all about how you think about it. Okay, how do we get the answer? What kind of question are we posing right here? And what did we talk about last week was how we look at the number one differently, and how should we look at number one in this case? To the power of 0, so that we can cancel them out, and therefore the answer will be 0. All right, log base 2 of 2, so it's 2 to the base to the power of 1, so therefore the answer is simply 1. Okay, and then log base 2 of 4. So the way we will look at 4 is going to be 2 squared. So log base 2 of 4 is equal to 2. All right, so we're good. Okay, we're good. So if you're good with all these, and of course we can do any other basis. Okay, and can you see how they are all equal to 0? What is the reason why when we put a number 1 into the log function, somehow they all end up to be 0? So when we have these ones, okay, so the reason why they all equal to 0 is because these ones could be written as 2 to the 0 power, 3 to the 0 power, right? 4 to the 0 power, or 5 to the 0 power, right? So that's why they all equal to 0. Okay. Now, if you wonder, why am I asking you these questions? Because these questions actually would be very helpful in helping us making these graphs. Okay. So now, I would say the graphs here will be somewhat more interesting here. Now, again, you only need 3 points, right? You only need 3 points. So my question is this: what kind of number would you want X be so that you have yourself a very nice graph? Now, if you put in 0 right here, that actually would cause a problem. Why would putting 0 right here cause a problem? And this is a very important question. Same thing. So same thing. Okay. So so you cannot rewrite the 0 as 2 to any power. Okay, it's not possible. And because of this, actually, I'm thankful for you suggesting that, because that makes my job a little bit easier to propose that we have a vertical asymptote right here. Remember how we had a horizontal asymptote for exponential function, right? At y equal to 0. Well, we have the inverse, right? So we're just going to switch the x and y around, so that becomes x equal to 0. But the real reason, is that you just can't have x value equal to 0. There's no way. Okay, that would never happen. That couldn't even happen. So what other x values would be your preferred value? 2. 2 would be nice. You can also put 1. Would you like 3? No, 4. 4. Okay, 3 is not a nice number. So you think about, what is log base 2 of 1? That would be 0. So you have a point at 1, 0, and that would be our x-intercept. I hope you understand why last Friday's step is so important. Because now you know what you're reading, you know what you're thinking, and now you know how to be a smart kid in proposing some nice x values for yourself. You are not blindly thinking about, I'm just going to do a 0, 1, and 2. You're purposefully designing some x values so that you have a good time graphing it. And then log base 2 of 2 is equal to 1. We did it earlier. Log base 2 of 4, it's equal to 2. So 2 comma 1 and 4 comma 2. So it looks somewhat like a square root function, but it's different because it goes all the way down, okay? Because it leans towards the asymptote. Okay, if you have a very, very small decimal number as the x value, then you have a very negative answer because to do a very negative power, it's a small, tiny number. So that's basically the graph. And to write down the domain and range, I think that's very easy to tell based on the graph. The domain would be 0 to infinity, okay, parentheses. And the range would be negative infinity to infinity, okay? So you may look at the graph and tell all these domain and range stuff, or you can say, well, I knew the domain and range for the exponential function, so I'm just gonna change and swap them. Either way, it's fine, but this is gonna be a key graph, a very key graph for you, okay, to make sense, okay? Exponential graph goes like this. All right, logarithmic graph goes like this. Okay, so that's the major difference between these two major functions. Very good.